In this video, we will derive the third kinematic equation. For this, let's consider the first problem we did for the kinematic equation number 1, the problem with Dr. Perry, where Dr. Perry was jogging at 2 meters per second, accelerated at 3 meters per second squared for 2 seconds, and we found his final velocity was 8 meters per second. So in this particular problem, instead of looking for the final velocity, we're interested in trying to find Dr. Perry's displacement. So now with information from the first problem and what we found, we know the initial velocity is 2 meters per second, the final velocity is 8 meters per second, the time period over which we did this was 2 seconds, and we're trying to find the displacement. Now, just using the kinematic equation we derived in the last video, the kinematic equation number 2, we plug in our information and we get that Dr. Perry had a displacement of 10 meters. But let's say that we didn't want to actually have to take the step of finding his final velocity before solving for the displacement, and instead just wanted to take the information of knowing the acceleration, the initial velocity, and the time to be able to solve for the displacement. So with that, we can take the equation that we just derived, the second kinematic equation, and the first kinematic equation, and combine them by putting in the final velocity in the equation for the final velocity in this equation in for that equation. So when we plug that in, we get this, and we can simplify it to give us the final third kinematic equation, that the displacement is equal to the initial velocity times the time plus 1/2 AT squared.